sun rolling high, the sapphire sky beats great and small on the endless round. It's the circle.
Unit! So at this point, you should be close to having memorized the sine and cosine of angles that are in the first quadrant, whether we're talking degrees or radians. So we're just going to roll through a couple here. This is from a card game that we would have played, but I'm just going to have you say what it is. So we've got sine of pi over 4. So I'm just going to give you a few seconds for each one. Think about it. It is radical 2 over 2. And that is cosine of pi over 4 as well. All right, sine of pi over 6. It is 1/2. Cosine of pi over 6. It's radical 3 over 2. And then our last one today, cosine of pi over 3. Is 1/2. Okay, so for any of those, if you're not able to think of them quickly enough, go back to the resources that I shared last week and start working on them, especially the ones from the first quadrant. That is something that you're going to want to be able to recall quickly. It's something that I know in calculus, we may not do some of the more complicated things in trig, but these reference angles, finding the sine of pi over 6, comes up randomly all the time. So that's something that we need to have memorized so that we can use it quickly. So today we're going to add in the other 3 trig functions. So we've got our sine, cosine, and tangent, the ratios for those. Just recalling that for cosecant, we're talking about the reciprocal of sine. So you could say that it's 1 over sine. Or you could also say, since we're taking the reciprocal, we could say that it is the hypotenuse over the opposite. For secant, it's going to be the reciprocal of cosine. Or we could call it the hypotenuse over adjacent. And then our last one, cotangent, is the reciprocal of tangent. Or we could call it adjacent over opposite. Going back to our trig chart from last week, we are going to fill in the cosecant, secant, and cotangent for each of these angles. And really it's as simple as looking at whatever trig function is the reciprocal of it and finding the reciprocal. You'll notice that some of these are going to be a lot easier than others. So like the reciprocal of 1/2. All of the 1/2s are going to be easy ones to find, that I'm just flipping that 1/2 to get a 2 or a -2. Those signs are still going to apply. So if sine is positive in the first and second quadrant, then cosecant is also positive in the first and second quadrant. Same for cosine and secant, tangent and cotangent. They're going to be positive or negative in the same spots. Some of the trickier parts of this, when we're taking the reciprocal of 0, technically would be like 0 over 1. So when we flip it, we're going to have 1 over 0, which is undefined. So anything that was 0 to begin with is going to be undefined in our reciprocal. Anything that was 1 to begin with, really this is 1 over 1. So when I flip it, it's still 1. So my 1s are still going to be 1s, -1 is still going to be -1 when I take the reciprocal. And then we're brought to this radical 2 over 2 and radical 3 over 2, which we see a lot in sine and cosine. So once we find the reciprocal of them once, we're not going to have to do that again. But if I take the reciprocal of radical 2 over 2, I'm going to get 2 over radical 2. And then it's just a matter of rationalizing it. And we actually had to rationalize this one at the beginning in order to get it to look like radical 2 over 2. So you could just recall what it came from, but that's okay if not. So you've got this square root of 2 times square root of 2 is square root of 4, which is 2. So we just end up with radical 2. For any of those radical 2 over 2's, we're just going to end up with radical 2. So we've got radical 2 there and there, a negative radical 2 and a negative radical 2. Okay. So now our last one for cosecant, is looking at the radical 3 over 2, so 2 over radical 3. And then simplifying it, we get our 2 radical 3 over 3, and this one doesn't simplify like the last one did. It is just 2 radical 3 over 3. So any of the places where I had my radical 3 over 2 for sine, cosecant is going to be that 2 radical 3 over 3. So because secant is going to be really similar, just finding the reciprocal of cosine instead of from sine to cosecant, finding the reciprocal of sine. Pause the video, see if you can go ahead and find all of the values of secant for these angles. Which brings us to cotangent, and still finding the reciprocals of tangent here. So same process, but we do have a few that are different. We've got our zeros that we can go ahead and say the reciprocal is undefined. We've got our ones that the reciprocal is still going to be 1 or negative 1. We do have an undefined in here. Tangent had some undefined, so if we were undefined to begin with, that means that it had a denominator of 0 because it came from this 1 over 0 to be the tangent. So if I flip this, it's going to be 0 over 1. So we are going to get 0 instead of undefined when we flip those, that's 0 over 1. And then our other two we're going to have to calculate. So we've got this radical 3 over 3 that we're going to be finding the reciprocal of. So 3 over radical 3. Sorry, this marker is not great. But we're going to get radical 3 for those. So it's kind of interesting because we took the reciprocal of radical 3 over 3 and we got radical 3. So do we think that the opposite is going to happen for radical 3? So if you take the reciprocal of radical 3, so just 1 over radical 3, and simplify it, we're going to get radical 3 over 3. So very interesting. I've got like some disappearing ink going on here. Very interesting with these that they end up being reciprocals of each other. So anytime that you've got this radical 3 over 3, the reciprocal is going to be the radical 3. And anytime you have the radical 3, its reciprocal is going to be a radical 3 over 3. As we fill in the rest here, we just want to make sure that cotangent is still negative in the places that tangent was negative. So in the second and the fourth quadrant, got radical 3. And there you have it. We've got the whole trig chart. So the last thing that we're going to do today is just a few examples where we're really trying to pull together everything that we've learned about trig so far. So for both of these examples, we're trying to find all 6 trig functions for whatever angle they give us. In example 1, they give us 7 pi over 4, so one of those angles from the unit circle. But don't look at the chart, put your chart away. We're going to start this one from scratch and think through the whole process of how we would get each part of this. So something that we might be thinking, since it's in radians, just noticing that the denominator is 4. So that means my reference angle is going to end up being pi over 4 or 45 degrees. So I'm going to be using sine and cosine of 45 degrees. So it's important that I have those first quadrant angles memorized, because if I know sine of pi over 4 and cosine of pi over 4, this is going to be a breeze. Now I do have to consider the fact that 7 pi over 4 is not in the first quadrant, so I do need to figure out where it is, because that's going to determine whether my sine and cosine are positive or negative. So looking at my 7 over 4, I might notice that it's not quite 2, but it is in between 1.5 and 2. So I'm stuck here in the fourth quadrant. This is where my 7 pi over 4 is. But it is going to have the reference angle pi over 4. That's that angle from my terminal side to the x-axis. So that's where it's definitely going to help to know sine of pi over 4, because it's going to be the same thing, but then might be positive or negative based on where it's at. Remember that my sine and cosine are really my x and my y value, where cosine is my x and sine is my y. So I'm just asking myself, as far as positive and negative, my x here is positive because it's in the fourth quadrant, but my y is negative. So that means that my sine of 7 pi over 4 is going to be a negative. My cosine of 7 pi over 4 is going to be positive. Tangent of 7 pi over 4, since I'm dividing sine by cosine, is going to be negative as well. And then I have to just go with what I have memorized for sine and cosine of pi over 4. So if I know from my unit circle that my sine of pi over 4 is radical 2 over 2, then it's just as simple as saying, okay, I know that's what it is for the reference angle, and then it's going to be negative. Same for cosine of pi over 4 is radical 2 over 2. And then if I divide them, I'm going to get that negative 1. So now we're just going a step further, and we're going to find the cosecant of 7 pi over 4, which, remember, we're just finding the reciprocal. It is still going to be negative. If we remember from our trig chart, the reciprocal, when we do this 2 over radical 2 and then try to simplify it, we're going to end up with radical 2. If you have to go through and redo that process every time, not a big deal. Kind of saves us a little bit of time here, though, if we know what it is. So same thing for secant, taking the reciprocal, we're going to get a positive radical 2. And then for cotangent, our reciprocal of negative 1 is negative 1. So there we are. With example 2, we're actually not given the angle itself, but we are given a point that is on that terminal side. So we're talking about this angle where it lands, and x is 12 over 13, y is 5 over 13. This is actually example 2 in your textbook. So if you're looking back at example 1 or 3, you can kind of use this as a reference. So really what they've told us here, they told us even more than they did on the last one, because this last one we had to figure out what that reference angle was and then use it to find sine and cosine. On this one, we don't want to overcomplicate it. It really doesn't matter what this angle is because they've already given us cosine and sine. Remember, cosine is always the x value, sine is always the y value. So it doesn't matter what theta is here, but our cosine is going to be that 12 over 13. Sine is going to be the 5 over 13. And then for tangent, and I wrote these opposite, so you gotta be careful here. For tangent, I'm dividing my sine divided by cosine. So I'm just taking that 5 over 13 and multiplying by 13 over 12, multiplying by the reciprocal. My 13s are going to cancel, and I get that the tangent is going to be 5 over 12. And this is nice that these cancel. That is always going to happen because they're always going to have the same denominator. It came from that hypotenuse, so it's always going to be the same. Okay, so now we've got the secant left, cosecant. I'm going to run out of a room here, but the cotangent here at the bottom. And I'm just taking the reciprocal of each of these. So my secant is going to be 13 over 12. Cosecant is my 13 over 5. And then cotangent is 12 over 5.